Okay, so I have a special request. If you're standing in the back, would you please sit in the front row? I have no idea why the organizers left the front row vacant. Maybe it's for Boris Johnson, who knows? Anyway, I'm Mike Stonebraker. I'm on the faculty at MIT, sometimes called the Oxford of the West, maybe. And I'm a database person. I guess my main claim to fame is I wrote Postgres. I also won the Turing Award in 2014. I'm also the founder of Tamer, and I'm here to talk about data mastering at scale. So the outline is very simple. I'm going to remind you what data mastering is. And then I'm going to talk about what is data mastering at scale. And then I'm going to tell you why all the traditional solutions that are all probably already in use in your company fail. And then I'll tell you what works, and the teaser is machine learning. So what is data mastering? Well, you folks mostly work for enterprises, and they're full of data silos. Why do enterprises create data silos? Well, the answer is they create independent business units and tell the head of the independent business unit, go make something happen. And that person then assembles whatever data he needs and whatever solution is available at hand, and he creates the data silo. Why in the world does your enterprise work this way? Well, if you don't, then all decisions have to go through God, and it takes forever. So agility says, divide into independent business units, tell them to make something happen, but then you get data silos. And agility is the complete reason why you want to do this. However, that gives you a huge downstream problem, which is there's enormous business value to integrating data silos after the fact. Why is that? Well, if you work for the refrigerator division and your friend works for the jet engine division, if you're selling to Tamer and the jet engine guys want to sell to Tamer, they'd like to figure out who your contact is. That requires you to integrate customers across these data silos. Just one more. Turns out Carnival Cruise Lines is a Tamer customer. They're the guys with the big white boats. It turns out Carnival is an amalgam of 9 different cruise lines. Royal Caribbean is one of them. Costco here in Europe is another one, and there's 7 more, including the cruise line branded as Carnival. Well, the Carnival, the amalgam of nine cruise lines, wants to share spare parts. After all, everybody uses the same kind of straws. So they have 9 different supply chains, and they want to be able to share parts. That requires you to integrate parts over these 9 different enterprises. So sharing spare parts requires you to integrate parts. So people integrate parts suppliers, customers, research data, oil wells, ... Huge, and they do it for business value. And the problem this creates is that you need to, after the fact, integrate independently constructed data sets. Now, if you take away nothing from my talk other than the following, tattoo this on your brain. Independently constructed schemas are never plug compatible. They never have the same key, never. And I've never seen one that does. Now, maybe you're lucky and you've seen one somewhere, but that never happens. So independently constructed schemas never are the same, and so you need to, after the fact, integrate data that was not meant to be integrated. What do you have to do? Well, life is pretty straightforward, if a bit complicated. Standard wisdom, move move your data set, move my data set to the same place. Think of that as a data lake, data warehouse, whatever, S3. Then if you're the human resources person in London, I'm the human resources person in Paris. You have employees, I have employees. But you pay your employees in pounds, I pay mine in euros. Got to do transformations. You call them wages, I call them salary. You got to integrate the names of stuff. Worse yet, if I'm the guy in Paris, I pay in euros, but I pay after taxes and with a lunch allowance. You pay gross in pounds, no lunch allowance. So if you just transform the euros to pounds, you get two salaries that aren't comparable, and you put them together, you get garbage. So transformations, schema integration, in round numbers, figure 10% of your data is wrong or missing. My favorite example is, for some reason, data scientists are prone to use minus 99 to mean null. If you just use minus 99 without realizing it means null, again, you get garbage. Often, there isn't enough signal to put stuff together, so lots of people join their respective tables to other external data sets just to get some more fields to help out. And then comes the heavy lifting. You want to do what's called entity consolidation, also known as deduplication. If you're the English HR guy, I'm the French HR guy, there may be an employee who works for both of us, and you've got to deduplicate that's the fact. That creates clusters of records thought to be the same thing. Then most everyone wants to reduce each cluster to what's called a golden record, which is, I want to know that it's Mike Stonebraker, and MR Stonebraker is the same thing, but the various tables may have different addresses, different ages. There's some preferred notation usually. So I have to find golden records. Lots of time at the end of all this, I want to perform classification. If I'm integrating suppliers, I may want to classify them as either international or English. And then, of course, there are no static problems. You then have to do this over time on an ongoing basis. So that's what silo integration entails. And if you want to do it, then you have to create a pipeline of some number of the previous actions in some order, and I'm going to call that data mastering. Now you can call it master data management, data curation, data integration, data unification. All those mean the same thing. Put silos together with some pipeline of this kind of stuff. So that's what data mastering is all about. In your enterprise, if you want to integrate data sets that were written by independent business units, this is what you have to do. So in this talk, I'm going to worry about three of the harder problems in that pipeline, namely schema integration, put your salary as my wages, entity consolidation, find the duplicates, and classification, classify them as international or English. So what does it mean to talk about data mastering at scale? If you have 1,000 records and I have 1,000 records and you want to put them together into a composite data set, use anything you want. Do it on your wristwatch, do it manually, doesn't matter, do something. At scale means when that becomes really hard. So tamer customers often have millions of records, hundreds of entities, hundreds or thousands of data sets, And inevitably, there's an ongoing stewardship problem. So at scale means it's a big data problem. If you have a small data problem, take this opportunity and leave and go make some better use of your time. If you've got to do this at scale, that's what this talk is about. So who's got this problem at scale? Well, let's look at schema integration, the first of our three issues. GlaxoSmithKline is a Tamer customer. The gleam in their eye is they want to integrate research data. They have thousands of data of scientists, biologists and chemists who are doing wet stuff in the lab. And if you're in Germany and you're making some gook out of components, and I'm in the US and I'm making the same gook out of something else, then social networking should put us together. We want to find out, we want to share notes on how to make gook. So GlaxoSmithKline wants to integrate essentially all their research data. That's millions of tables. And they figure they have at least 10 million columns. So at scale means these kind of numbers. Toyota Motor Europe is another Tamer customer. They, of course, sell Toyotas here in Europe. And way back when, they created independent distribution in every country, and often at finer granularity than the country level. So if you buy a Toyota in Spain and you move to France, Toyota develops amnesia because it's a totally independent system. So they want to put together all European customers. They're in more than 250 databases in 40 languages, and there's more than 30 million of them. No common keys. The schemas are never, ever the same. So this is what you have to deal with if you want to do entity consolidation at scale. Here's another example that I'll talk about later. I can't name who the media company is, but it's one of the Hollywood ones. And they want to master titles of movies, records, content. And of course, there's no global key. So they want to deduplicate it so they know who's using what, and also for royalty purposes. So they've got nearly 8 million records, and consolidating them makes it go down by about a factor of 6 into 1.5 million golden records. So that's their deduplication problem. And I use this one because I'm going to talk about it again. The last one is somebody with a classification problem. GE is also a Tamer customer. They want to classify spend transactions. When you submit an expense report, you took the T to get out here. That's a line item in an expense report. The CFO of your company probably wants to classify that into something so he knows how much T usage your company is using. So they have 20 million transactions, and they want to classify them into a pre-specified spend classification hierarchy. So just thing to take note of is 20 million. Okay, so that's the problem Tamer customers and most of you are facing, which is do this stuff and do it at scale. So why do the traditional solutions from the usual suspects, why do they fail? Well, the standard wisdom, if you want to do schema integration, is I put table A and its columns up on the left of my screen, table B and its columns on the right, and then you start drawing lines between salary and wages. Lots and lots of interfaces do exactly this. Why doesn't that scale? Well, imagine trying to do this for 10 million attributes. You're going to get carpal tunnel syndrome for sure, and it's going to take forever. So this just is a non-starter at scale. Anything human is not going to work. Okay, so how do the traditional guys say you ought to do entity consolidation? Okay, they all say the way you do it is you have a match problem to create clusters and a merge problem to do the golden record stuff. They all say, without exceptions, use a rule system to do that. So, for example, if the edit distance between names of things is less than such and such, then consider them the same entity. Simply a rule. Write some rules. And another rule is if you have a cluster and there's a bunch of different addresses in it, take the most frequent value. Another rule. So the traditional guys say, write a bunch of rules. Why doesn't the traditional solution to entity consolidation scale? Well, here is exactly the data from this media company. They wrote 200,000 rules to deduplicate 7.8 million items. Now you're already laughing. They actually did it. It took them 13 years times 2 people. So 26 man-years went into writing 200,000 rules. And if you think this is a nightmare, you're absolutely right. It's essentially unchangeable. And to add a new data source takes forever. And changing anything, is essentially impossible. So if you do this, I guarantee you that the person who gets your job after you get disgusted is going to hate you. This stuff simply doesn't scale. It takes too many rules to do real-world problems. So, if you're doing classification, what's wrong with rule systems? Well, again, the problem is I've got spend transactions, so I'm going to classify anything from Staples as office supplies. Perfectly reasonable rule, but now you have to write a whole bunch of them. So the general wisdom, and tattoo this on your brain also, is that a reasonable person can write about 500 rules, and after that you get exponential complexity. So imagine what you want to do is write only a small number of rules. So what did GE do? They did exactly this. They wrote 500 rules, and it classified 2 million out of their 20 million spend transactions. That gave them a huge problem. To classify the rest would take well more than 5,000 rules, because they wrote the more common ones first. So it would be absolutely daunting to solve this using a rule system. So again, rules don't scale. Period. End of story. So what do you do instead? The traditional solutions are simply not going to work. The landscape is littered with failed projects who've tried to do this and found out that rule systems just don't scale, and anything involving drawing lines doesn't scale. So you have to assume this is a machine learning problem. So you have a task at hand to apply machine learning, get some training data, then train a model, and have it do the rest of the work. So, if the desired task is to classify all 20 million GE spend transactions, well, get some data. Model predicts the desired value for the rest of the data. And if you're not using active learning, you should, because you always make errors. You have a human fix the errors and then update the model. That's what active learning is all about. So use learning, use machine learning, use active learning. And the training data, how are you going to get that stuff? Well, in GE's case, you need a lot of training data, hundreds of thousands of records, and you can't do this by saying, here's a transaction, classify that as office supplies. If you do it manually, you're dead. So you've got to do something more automatic than that. And I have nothing against rule systems. Use a rule system. And if you don't have any training data lying around, and if you have some lying around, God bless you. If you don't, you've got to get some. And use a rule system to get it if you want to. And I have no problem with doing that. You're going to have a human look at the rules, decide whether you like them, and use active learning to improve the training data. And if you do that, well, that's exactly what GE did with help from Tamer. They used their 500 rules to generate 2 million records of training data, trained a machine learning model which classified the rest of the data, and it worked like a charm. So that's how they classified 20 million spend transactions with a machine learning solution. So think machine learning, that's the only thing that's going to scale. Now, running machine learning is not all that easy. There's a whole bunch of gotchas. So others in the show today have mentioned skew in training data. Which is if you have training data and it only deals with London, it's not going to predict the north of England very well. So you have to be a little careful about training data. Training data will have errors, for sure. If it's generated automatically using any technique, it will have errors. You have to use active learning. You have to be smart about looking at the data. You can't look at it all. You have to look at a sample and train the model actively. And ongoing stewardship is always a problem. It's always a problem because you are going to have, there's no such thing as ground truth ever. And so you're going to say, how good is the machine learning doing? The answer is you're going to have a human look at a sample and decide whether you need to train some more or improve the model or whether it's good enough. That's going to be a human thing. And if your model is classifying plumbing supplies and also office supplies, you may have a different person doing plumbing supplies from office supplies. So there's a fair number of gotchas. So this is not for the faint of heart, but it's the only possible solution available to you. I'm just going to skip this because I'm almost out of time. So if you're doing data mastering at small scale, use anything you want. Do it on your wristwatch. Use any one of the traditional systems. Chances are your enterprise already has one of those in-house. It will work fine at small scale. Data mastering at large scale, you cannot use a rule system to do that. It simply won't work. Rule systems don't scale. Anything manual doesn't scale. Generating training data manually doesn't scale. That's fine for pilots to sort of dip your toe in the water, but it is not going to work at scale. So it has to be done using ML, and it's got to be done with some way to get training data, which is not one by one with a human. And this is often an engineering challenge. So if you embark on this path, make sure you either have or hire competent talent to help you out. Now, what happens if you are running one of the traditional solutions? Well, I guarantee you your in-house people who use that system will try and sell you on using them. It's not going to work. And the trouble is you have to do schema integration. You've got to do deduplication. You've got to do often classification. And at scale, those have to be ML. And there are no solutions from the traditional vendors that do that using ML. So you're about to tell me, yeah, but my traditional vendor told me he's using machine learning. Yes, he will tell you that. His marketing guys have glossy stuff that says we use ML, but it's not for these three problems. They're using it for something else. Something else is, for example, if I have a solution that classifies spend transactions, it's conceivable that my model could help you if I'm willing to share my model with you, which is not going to happen. So that's another ML problem, and the traditional vendors, in fact, do some of that kind of stuff. But the question to ask them is, what do they do for schema integration, for deduplication, and for classification? Those are the hard problems. And if you have a solution that doesn't do any of that, then you've got the wrong vendor. So come see Tamer, they're out there someplace, and they use machine learning for exactly this stuff, not for something else. So go to our website, talk to those guys, visit us out there. So that's what Tamer does. The one thing I should remind you is I mentioned earlier about Carnival Cruise Lines. Well, Carnival wants to deduplicate parts. So each of their nine cruise lines, in fact, has a parts hierarchy, and so they know, for each cruise line where it is in the local hierarchy. So one possible strategy is to integrate the 9 hierarchies into an Uber hierarchy, and then integrate the local hierarchies into the Uber hierarchy. 2-step process. Another algorithm is to just take all of their parts and directly classify them into an Uber hierarchy. So there's a fair amount of algo that makes a difference here. And again, this is something that you have to think about at scale. I'm done. I have 2 minutes left. Maybe I made somebody mad. Thank you very much.